Hello students, and once again welcome back to the Chem School. As you know, in the last class we spoke about anti-Markonikov rule, and previous to that we spoke about Markonikov. So I also specified that today we are going to take a comparison between Markonikov and anti-Markonikov rule. So let's take few reaction and learn where to apply each of those rules so that you have a clear picture about these reactions. So let's get started. Now have a look at both the reactions. I have given you all the conditions that is needed for Markonikov, anti-Markonikov along with the mechanism. Okay. So what you are supposed to do now is predict which of them will follow Markonikov rule and which of them will follow anti-Markonikov rule. Okay. So you just need to predict that and then make the products that is needed. Okay. So just have a look and try to solve it on your own. Okay. Pause the video at this particular point and get the answer. I am continuing, okay? So have a look. Now, if you have a look at this, it's an unsymmetrical alkene. This is also an unsymmetrical alkene. So we said that for Markonikov and anti-Markonikov, you need unsymmetrical alkene and unsymmetrical reagent. So we have that, okay? For anti-Markonikov, you need peroxide. So we have benzoyl peroxide at both the places, okay? But don't get confused. We said only HBr in presence of peroxide will show anti-Markonikov, right? So have a look. All the conditions here satisfy anti-Markonikov rule, and therefore this reaction is going to follow anti-Markonikov rule. Is that clear? You have HBr, you have peroxide, and you have an unsymmetrical reagent. That is the reason this will follow anti-Markonikov rule, right? The next thing, if you have a look at this reaction, you have HCl. We said that HCl does not show anti-Markonikov rule. Why? We have seen the reason. That is, the next step is endothermic. Okay, that is the product formation is endothermic. That is the reason. Peroxide here is just given for confusion. Okay, so the effect of peroxide is completely ignored over here. Okay. So do not pay attention on the peroxide. So still, because you have HCl, you will still get Markonikov addition. So the second reaction is going to follow Markonikov rule. Now prepare the product. What we said for anti-Markonikov, okay, the H will go to carbon. I repeat, the H will go to carbon with less number of hydrogen. So amongst the alkene, this has one hydrogen, this has two. So H will go to this particular carbon. Okay. So now make the product. Let's use the red pen only. So you get CH3, then CH was there, one more H. So CH2, then this is CH2. The other part of HBr will go over here, that is Br. And you get the product as 1-bromo-propane. I hope this is very clear, right? Have a look at the next one. Because we said it is Markonikov, H will go to the carbon with more number of hydrogen. It means H will go over here. And Cl will go to the carbon with less number of hydrogen. So prepare the product. So what we get is CH3, CH with Cl. Okay. And this CH2 will take one more hydrogen to give you CH3. So the product is 2-bromo-propane. And we are very clear with the mechanism why this stuff is happening. Okay, so let's take two more examples to find out what are going to be the consequences of the reaction. Now have a look at these two examples. Okay, and let's try to predict the product. Now in this case, if you see, we have again taken propene. Here we have the reagent as HBr, and we have taken CCl4, which is the solvent. It is a non-polar solvent. So solvent, okay, it's just a medium for your reaction to carry on. So this is of no point to us, okay? So this is just again given for confusion. Have a look. Is there any peroxide in the reaction? No, there is no peroxide. It means now even HBr will follow which reaction? I repeat, HBr in presence of non-polar solvent will give you Markonikov. Okay, so follow Markonikov rule and predict the product, okay, and draw the product. So in this case, again, you will get the product as CH3, okay, CH2, okay, go ahead. H will go to the carbon with less number of hydrogen. So CH becomes CH, 2. Okay, and Br will go to CH2, giving you CH2 Br, that is 1 bromopropane. Okay, so that was very simple. The next one, you have HBr, you have peroxide, and you have unsymmetrical alkene, right? So now we are very clear that this will follow anti-Markonikov rule. But I want to teach you one more important factor, and that is, remember, whenever we were trying to draw anything, we always took into consideration the stable intermediate. Okay, so in case of Markonikov and anti-Markonikov, in both the rules you will get stable intermediate, and the stable intermediate will decide the product. Is that clear? Fine. Even here we know that it is going to follow free radical mechanism. Okay, and as per free radical, the tertiary radical is more stable than secondary, and the primary radical is the least stable. So we know that the product formation is as per the stability of the radical. But when you do Markonikov, okay, you also do rearrangement. I repeat, if the radical is on secondary, okay, like this, suppose you have the radical on secondary, okay, so what you will do, you will move it to tertiary, because tertiary is the neighboring carbon, right? But whenever you take HBr with peroxide, do not do rearrangement. That is what you need to remember. No rearrangement. Of free radicals. Okay, so in Markonikov we were doing, for the cation we were doing rearrangement, but for anti-Markonikov we do not do any rearrangement. Just focus on the double bond and prepare your product. Okay, nothing more and nothing less. So now what is going to be your product? You will get CH3, CH, CH3. This will remain as it is, right? Next, CH will take what? Okay, will take the H, so that becomes CH2. Okay, and this CH2 will take the Br. This is your product. So no rearrangement of anything is going to take place over here, and that is going to be your product. So let's write down the name of the product. So now as per the numbering, Br is a substituent that will get the lowest numbering. So 1, 2, 3 and 4. Okay, so on 3 you have methyl, and 1 you have bromo. So 1 bromo, 3 methyl, butane. That is going to be your product. Okay, so when you see the options, you will get one option with this. Okay, I repeat, you will get one options with the Br at this particular position, or Br at this position, or Br at this position. So focus, draw your product, and then look at the option. Okay, don't look at the option and then decide which is going to be your reaction, okay, or which is going to be your product. So I hope from here onwards you will have no doubt with respect to Markonikov and anti-Markonikov. Okay, see you soon on the next class. If you have any doubt, please ask in the comment box. Bye.